and welcome to another episode of FooBar. In today's episode, we are going into the depths of different types of testing with serverless. If you want to know more about serverless, cloud computing, or software engineer practices in general, subscribe to my channel in the red button below. I post videos on Tuesdays and on Thursdays, and now on Mondays I'm doing live streams. So you should get notified when that happens. So let's get started! This is another episode in my series. This is not a podcast, and today we have a very special guest, Nicolas Moutschen. I hope I said it right. We are going to talk with Nicolas about the different design principles that should guide us in designing serverless applications. We are talking about monorepos, and then we are spending a lot of time talking about testing. We are looking at code and how you can implement those tests. What are good practices, what are bad practices, and all kind of things. So we are going into the depth of unit testing, performance testing, integration testing, end-to-end testing. So let's get to the interview. Hello and welcome to another episode. Today I have a very special guest, Nicolas Moutschen. I hope I say it right. I always suck at doing this surname pronunciation, but I will get better. He's a solution architect with a specialty in serverless. I'm super happy to have you here, Nicolas. How are you doing?
Good, and thank you very much for having me today. And in terms of the name, you nailed it. So
I always try. There are some harder than others. So first, tell me, what is a specialist solution architect? I think you're the first one that is here.
Yeah, so I'll start first of all to explain a bit what is a solution architect within AWS. So solution architect is a team of people that help customers in terms of their technical questions, designing, architecting. So not there for support, right? We're not there to troubleshoot things that are wrong, but kind of, hey, you want to do things a certain way. Solution architects are there to advise customers in terms of how they should go about building things, what tools can they use and so on. As a specialist, I, as the name indicates, I specialize on serverless technologies, right? So instead of being a generalist, I know a bit about all the services, and there's quite a lot of them, right? I decided instead to go the easy way and only focus on the set of services. So that's things like Lambda functions, of course, but an API gateway, step functions, event bridge, SNS, SQS. Then you also have lots of things that are, often used in a serverless architecture, right? AppSync, DynamoDB, and so on and so on.
Yeah, all my favorite services, basically.
Yeah, basically the ones where you minimize the infrastructure management aspect to really focus on building things, right? That's kind of what I'm passionate about.
Yeah, that's the part I love from the cloud. I didn't like the cloud before serverless. I didn't understand why to have all these kind of things. So much cloud formation, it scared me, and now I love cloud formation. So
yeah,
it's just a matter of what you put inside of it.
Yeah, cloud formation for VPC can be daunting the first time you have to do that. But when you go serverless with frameworks like SAM and so on, it's just a few lines of code. A few lines of YAML here and there, and you're done.
And I am a developer by trade, so serverless resonates super well with me. I don't know about you. What is your past life before being a solution architect? Were you also a developer?
So I had my own startup before joining AWS, and we actually went the whole journey. We started with servers in the basements of our. I started in my father's home with 1 or 2 servers just hanging there. We moved to an office, had the servers in the basement, and we needed the space, so we started renting racks in data centers.
Wow.
And then, we realized that, hey, the cloud sounds like a nice idea. And the kind of triggering point was that someone cut our fiber optic cables one day. So that's kind of why we decided, like, hey, maybe the cloud could be a good idea. Yeah, and then there was a project where we needed, things that was just able to run on demand, when we trigger an event, and need to run in, all kind of regions that AWS proposes. And I thought, why not try Lambda? That sounds like a really good fit there. And after that, I was sold, right? So that's kind of the story I went through. I went through all the steps, all the pain points of managing my own infrastructure till I discovered serverless.
Wow, so that's really interesting. So when you talk with customers, you can understand how they're feeling depending on which step they are.
Yeah. It's often like, why are you managing that infrastructure? Like, try to be serverless as possible, right?
Yeah, that's super interesting. I didn't know that from you, so that's always nice to learn. But the topic of today, we are going to talk a little bit about design because I know that's something you're very passionate about. So, and I also like designing applications and architectures. So we are starting talking a little bit about that, and then we move to the core of the talk today, that is testing. So maybe we can start a little bit with the design thinking process of doing a microservice architecture that you want to do serverless. What are the steps?
So there are a few aspects there, right? The first one I would say is one thing I talk a lot when I talk about microservice architecture is boundaries. So what is in one microservice? What should be in another one? What are the responsibility within each other? And actually, that's something that's not easy. If it's the first time you're doing a microservice architecture, it's kind of the thing that you need to think about, and you might get wrong. You do lots of experiments, and going back to serverless, like experimenting in serverless is fairly cheap.
I think for people that are coming from like maybe traditional computing, they think about microservices as a container or a little box. But when you come to the serverless world, a microservice maybe is a lot of independent little puzzle pieces. So how you decide what is inside this logical microservice that because it's not only Lambda functions.
Yeah, so if we go back, often when we talk about microservice, we say, hey, it gives you the ability to change things, innovate, and so on, fast and fast. The idea is that between these microservices, you will often have contracts. So if you define an API, if you think about containers, for example, you have this API and so on. Well, this tends to be rigid, and you have this rigidity because what you have within your microservice is completely flexible. Yeah. And so to your point, like around microservice in serverless, it's not just a Lambda function. It's going to be the API that you have, it's going to be Lambda functions, going to be the data as well. We often forget about this aspect, but the data should also be there. And you have this unit that you can then change everything inside that. As long as you maintain the contract that you offer to the other microservices, you're good. Yeah. And there can be lots of resources within a single microservice.
Will you recommend that everything inside of this logical microservice is inside one, CloudFormation stack that should be deployed all together, or we should put everything in different stacks? How you will architect it in a practical way?
I would advise not having a stack that contains multiple microservices because you want the flexibility to deploy each unit. Exactly. But I've seen two approaches that I think are interesting. So either this one stack per microservice, which is what I've done in a project we'll talk a bit later. But you can also do one stack for the data layer, one stack for the API layer, and one or multiple stack for the kind of business logic layer. The idea that is if you mess up with one of them, if you mess up with something on the business logic, you still have the data layer that's there in its own system. You don't risk, accidentally deleting that. You reduce that risk, right?
Exactly. So you have a little bit more complexity in your deploying, but then you have more security in how things are deployed. So that's a good strategy. I always do one stack per microservice, but it's always risky when you have all your customer data in the Dynamo table and you're like, praying to the gods.
There's also the thing is that microservices don't have to be micro, right? It's just a logical bounding unit. You could have a microservice with lots of resources in it, and then you have the limit of 200 resources in CloudFormation, for example.
But I think that's a different discussion. I think a little bit more philosophical discussion. What is a microservice? And I think that depends on the definition. For me, it works that a microservice tends to be kind of a small, or I will say that you can rewrite it in a couple of weeks or in a month, because if it's that big, then it's not something modular that you can replace easily, that it becomes like a mini monolith. So I think it's good to have an idea on how big your microservices you want to have them. I don't know, you might have a different view, but I try to
Totally agree. Like the idea is that in principle, you should be able to rewrite it, and they should be disposable. So you can. I had an example like this where I did a microservice in Python because it was simple to do, and then I'm thinking, now I've been playing a lot with Rust recently, and Rust would have really good performance for this use case, and I can just rewrite it in Rust if I want to.
Or even AWS released a new service that does exactly that, your microservice. So you throw the microservice to the trash and you plug that service in there.
Yeah, or the other way around. I've seen a lot of cases, you want to do something around personalization or image recognition. Well, you can start with what AWS offers out of the box, but maybe it's not, at the end, maybe it's not actually what you want to do anymore. You want something custom for yourself, but you already had that thing. You can just replace it and change these components.
Exactly. That's what I always like to think, that microservices are small enough that they can be easy to replace, because if you have these boundaries that are very good defined with APIs or events or whatever you want to have in the edge of your microservice, then it's so easy to just lift and put something else and use the real Lego.
You just, as long as you keep the contract, so the API or event contract, that's good, right? You can change anything else in it.
Yeah, I heard one, Yang Q, the serverless hero, Burning Monk, and he always says that when designing these microservices in serverless architectures, it's good to use like orchestration within the boundaries of your microservice, and then choreography outside. So basically, when you have to design how your microservices will connect to each other, if we use events. And then maybe inside your microservice you will use something like step functions or something like that. So what do you think about that? Is that a good approach?
When I read his article on the topic, I felt that he put into words what I was thinking, because I had to say a similar discussion a few times with customers, talking about that, like, should I use step function or should I use event bridge? And one example was around the latency sensitive workload, right? Step function gives you this kind of overview, end-to-end overview. I can see how long it's taking, especially now that we have X-ray for step functions. You have this observability there. But when you start to have this distributed with different teams, I like to think about microservices as in one microservice could be owned by a separate team. That's kind of my logical thinking there. Because of Conway's law, that the organization will end up,
resembling the system.
Exactly, and you can think about it the other way around. You can think about it both ways, and the idea is that if you have different teams that need to communicate, well, Event Bridge will be good for this, because then you just pass the messages around between the different microservices.
Yeah, I agree always with that thinking, and I think it's very confusing if you need to do step functions within multiple microservices, because there's just at least the express step functions is something fast that should be resolved within 5 minutes, so you don't want to send it around and wait, and you don't know what is happening. So I think it's nice to that analogy that the Burning Monk has. I think one thing that is very trendy now is the monorepos, and you have done one project. I think is one of the few projects I found around as an example project of a monorepo using serverless. And why you will go through the monorepo way? Why you started that project?
It's actually, when I started this project, I was not a big fan of monorepos.
Are you one now?
I actually am now. It was more, I wanted to do something, we have lots of really good examples on how to do one thing. If you look at the AWS sample organization on GitHub, there's lots of really simple, but really good examples, something that will show you how to do one thing. But we were missing, I felt that we were missing this kind of more complete pictures where you have, X microservices interacting with each other. And I was really inspired by Aitor's example, the airline application that he built. But I felt it was missing these really strict boundaries between microservices. So that was the idea there. And for convenience, because I don't want to tell people, look at these 10 repos I made, I decided to do a monorepo. But what I discovered doing through that is that it actually brought a lot of convenience around, having shared tooling, shared libraries, shared resources between all these different microservices. That was quite a convenient thing to have when I was doing that. And also being able, I'm thinking from, you have a new developer on your team and you want them to be able to understand how your application works. Well, here's the repo, here's your AWS account, deploy it, and you can start exploring the entire application, make changes everywhere and see a bit how it works. Like we have this single thing that can be deployed entirely.
Wow, that's pretty nice. So it's an e-commerce site basically with multiple microservices for different parts of your e-commerce. And you also have even the CI/CD pipeline. It's a full project.
Yeah, it's not a full e-commerce platform. I'll be honest with that. There are better examples out there. But it showcased
still a demo. Don't put your next e-commerce on there.
Yeah, no. There are better things. There are better folks from AWS that made some e-commerce projects there. But it was really the idea of having these different elements. So it's you have the order flow. So when you make an order, then you need to package the items for that order. You need to ship it. You need to process the payments. So all that are different microservices. And I wanted to show how can you interact, how can you create these interactions between all these components.
Yeah, and you apply the things that we were just talking before. How systems will communicate. So that's pretty interesting. I've been trying to do a monorepo with Node, and it's a little different because the tree shaking dependencies and all the packaging, it's a little painful. So I still have not got my head around being happy with the monorepo. I think it added a little bit too much complexity, so I end up having multiple repos separated. But it's something I would love to try out again, maybe in the future when dependency management is a little bit easier, because Node doesn't do, you pack the whole modules and it's like super fat, big things. So I think it's...
Well, I use Python. Python, doesn't do this kind of optimization.
Exactly.
So, it's just like we are used to it because it's Python, right?
Yeah,
but
exactly.
Yeah,
so maybe it has something to do with the language as well.
Yeah. But there was still, I still had to spend quite a bit of time on the tooling side of things, right? Getting the tooling right, understanding what I wanted to have there was quite important.
I like the way that you solved the deployment, because that was pretty interesting, because that was something I was seeing, like, okay, if I have code pipeline and something changed in the repo because code pipeline doesn't support monorepo, then it will be like, I will trigger all the deployment, and you didn't want to do that. So you had some kind of different pipelines kind of coming from the code pipeline. Can you explain a little bit that? Because
yeah, it's so the idea is that when you do a monorepo, you don't want to, as you said, you don't want to deploy all changes. You need to figure out a way to
find
the changes. And what I did is, instead of doing directly from the repo to code pipeline, I have a code build step in the middle that will look at the last deployed commit. And look at the difference between this and the latest commit and say, okay, which folder has changes? Which service folder has changes? And then it will just flag these and only rebuild these once. Store the artifact on S3.
Yeah.
And storing the artifact on S3 is actually what triggers each service pipeline.
Okay, so you're using the S3 integration with code pipeline instead of using the direct from GitHub or code.
Yeah, it's actually, I use both, because there are some artifacts that are retrieved from S3, but then it's also retrieved the entire project. So if you use code pipeline, you can have multiple sources in stage. And the first one will be used to trigger the pipeline, but you can retrieve other artifacts as part of that source stage.
Oh, that's super interesting. So I will leave the link for that repo in the description box so people can go and have fun looking at it, because at least I did have a lot of fun looking at it. And I'm pretty sure if they have any questions, they can ask you on Twitter.
Yeah. It's my DMs are open, or you can add me on, feel free to ping me if you have questions, or create issues on the repo. And if you want to contribute, it's an open source project. Contributions are welcome if you think you have a better idea on how to do some of the things.
Yeah, so let's go now to the main topic of today, that is testing serverless applications. And this is something, it's kind of funny because people ask me a lot of questions about testing. It's like this kind of dark place in the in the serverless world, like how I test my projects. I want to locally test them. Should we do that? Is that worth? Yeah. What are the different levels of testing? Maybe we can start from there.
Yeah, it's for me, I mean, I love the term layers of test because I think it's the important thing, and not see these layers as independent. You know, they are interconnected because they build one on top of each other. So, you know, you have, of course, the local test where you can test your code. So you can test that your functions in your code are working and so on. But locally, you can only do so much. Even if you use, if you want to integrate with DynamoDB local, okay, you can test, make sure and so on that it works. But are you testing the IAM permissions? No. Are you testing that you have your Lambda function configured correctly? No, either. You need to pass the DynamoDB table name somehow. That we usually do it with events, with environment variables. Yeah. And you can't test that locally. There are lots of things you can't test locally.
So you're also, like me, a fan of not local testing.
I think it's both, right? The point of test is to find potential issues fast, right? Yeah. That's the point. Because if you don't have tests, it's the end users that find the bugs.
Yeah, definitely. But I think unit test is very different than local test. That's kind of, I think, I really like unit test, and I believe that every function should have some coverage of unit testing because it's important for your maintainability and things like that. But local test, I find that it's very useful for rapid development. Like when you are trying something, you just want to run it locally, so you know that it's kind of working, but it's not something that will guarantee in the future that if this is still working as it should work. Because the service in the cloud change and you might not have your local stack updated. Things might differ, so I don't think it's the right security.
Yeah, no, it's. I've seen situations where people cannot use a new features from AWS that would be super helpful for them. The reason being because their local test system doesn't support it, and that's not a happy place to be in. Like you stuck yourself there. So that's for me a danger in this kind of situation.
Exactly, and as you say, there is so many things that are interconnected, like the environmental variables or things that might be coming from your CI/CD, like parameters or things like that, that you cannot really fake. Mm-hmm. and many services that are really not really well supported in the local. So I don't know, I'm not a fan of local testing. So maybe we can start with unit testing.
Yeah. Because local tests, if you use something like some local or things around, testing AppSync, okay, you can test some of it, but okay, now I use EventBridge. How do I test that, right? It's all kind of things, and that's the point there. So if you don't mind, I can share a bit. We're going back into the e-commerce platform. Yeah, so this is the repository for the e-commerce platform we were just mentioning. And because there's so much in terms of tooling, testing, and so on, I think it's a really good place to kind of look at that. And so as part of that, so first of all, I'm going to share, I'm a big fan of Makefiles. I know it sounds like an old technology. It's not super interesting one. But I'm a big fan of Makefiles. The reason being is that I mentioned earlier, I build something in Python. What if I want to change to Rust or Node or Go or something else? Makefiles don't really care about that, and that was a really great way to do this abstraction there. And it's also a great thing from the developer experience point of view, because if I do make all, this will deploy all services and run, linting, building, unit tests, check dependencies, package deployed, and run the integration test on AWS, right? It will do all these steps for me.
Nice.
So from a developer point of view, I can just do make all name of my service, and it will run all these things. But if we go a bit and start in steps, I'll start with the linting, actually. Because before we even run tests, we can just do some static analysis, right? We don't even need to run the code. And So as part of that, I mentioned the importance of tooling, and there is this shared folder that contains lots of scripts, and you can take a look. On the GitHub repo there's tools for the scripts, and then shared contain some shared resources. So in tool, I have a tool for linting, and we can see a bit what it does.
Are you linting the CloudFormation, or
yes,
what are you linting? Yeah.
And the code, of course.
Okay, nice.
Doing both. So like Lean CloudFormation, it's going to use CFN lint, which is a really nice tool. And pro tip, I'm going to show that in a bit, it's actually extensible. You can write your own rules if you want, and I've been using that. For example, you want to only use the latest available version of a language. For example, Python, you can use Python 2.7, 3.6, 3.7, and 3.8. And I want to say, no, we're only going to use 3.8. We want to make sure that you can have a rule for that, basically. And same thing for Python. I also have, a linter here. And because I'm using open API definitions for API gateway, I also have, the ability to lint there using a tool called Specky. So I can also validate that everything is good there. Ensure code quality, basically.
That's really nice.
Yeah. And so if I show a bit the linting, so I have some configuration here, but the rules part is, this custom rules file is going to be interesting there. Because I can create this, I can enforce certain rules if I want. So as I said, because it's part of a project that has certain deployment way to deploy things, there are some mandatory parameters. Every CloudFormation template should have these parameters. I can enforce that through here. Or as I mentioned, I want to enforce that it's using Python 3.8. I can do that through here and make sure that everyone's using Python, no one's using Python 3.7. So, and then going to the makefile piece, I can just type make. So let's hope that I'm not mixing, because there is an order, but I'm not good at memorizing it. So here I'm going to do the lint for the order service. And okay, found that there was one thing, but I'm within the threshold. It runs all the lint tests, and it's good, right? So, I showed that there's this command that allows me to run all the operations, but from a developer point of view, once it's configured, I can just do it like this.
Yeah, and that's pretty handy because you can run it locally even before committing to GitHub, and you will know.
That's actually something I'm a big fan. CI/CD, I see it more as a sanity check, and not as at the point where you should actually detect these errors, or you should detect these errors when you're still coding, right?
Exactly. And that's why unit test needs to be very fast, and linting and all this needs to be very fast, because then you can, for example, have your unit test running in your background all the time while you're coding, and you can basically see if you break something.
That's actually something, because I do build before I do the unit test. The reason being, I want to also test that my dependencies are correct. Let's say I start using a very new AWS service, but so Boto3 is the AWS SDK for Python. If I have an obsolete version, if I have an older version of Boto3 that doesn't support this new service, and I do some tests using my local version that has that, I'm not actually doing a fair comparison there. I'm not, not being as close to the real thing. So I also need to build to make sure in Python, it means fetching the right dependencies, just to make sure I test actually everything correctly. And then unit test. But for building, for the creation of time, I actually do some checks where I check if the function has changed or not. So I don't rebuild all the functions all the time, because otherwise that takes time, right?
Yeah, exactly.
Yeah.
And then these things needs to, at least in the developer side, needs to be fast.
Yeah. It's 1 minute, saves lots of time. Because if it's 1 minute and you want to do 50 tests per day, 50 cycles per day, that's 50 minutes.
Yeah.
So but then we go into my script for the unit test. And then here, for Python, so it's just doing some sanity checks if we need to do the test, but I'm using PyTest, which is a very common testing library in Python. And also have some checks and some cleverness because I also want to do code coverage.
What is your take on code coverage for Lambda functions?
I mean, I think getting to as close as possible to 100% is a good thing, but sometimes I have an approach in my code to have also layers of checks. Even though API gateway is supposed to be structured in a certain way, if I have an API gateway event, I should have a body key, right? But what if I misconfigured something? So I like to also have another check in the Lambda function itself. These kind of things tend to be, if I want to have 100% test coverage, I'll end up with lots and lots of tests. So choose something that makes sense. 90% might be enough. And also, test coverage doesn't mean that you actually test everything.
Yeah, at least my experience with Lambda functions, that if they are not that complicated, you really don't need that high coverage, because sometimes we just use them to glue two things together. So but if you are doing some business logic, that is something that you need to do some calculations or some processing or something that is a little bit more there, the coverage is more important because you want to test the happy flow, the sad flow. But if you're just grabbing a Lambda function and storing a file in S3, maybe there is not really a lot to test there because it's just an integration kind of component. But it's different if you are grabbing and creating the file and doing some calculation and aggregations, then you want to have proper testing there, because it's a little bit trickier than maybe in a traditional environment where you say we need to be 100% covered. And I think every Lambda function is an independent thing.
I mean, there's something like, for example, even a simple function that will take an S3 object, do some changes, and then put it back into another S3 bucket, for example. Well, you need to test that you're actually reading the event correctly. It's part of the layered test approach. I want local tests that I can run fast that confirm my integration test, right? So that's hopefully, if my local test fails, the integration test should fail. And
let's hope so.
Like if you have a situation when your unit tests don't fail and your integration tests are failing, there are two possible scenarios, right? It's either because it's an issue that you can't test and the integration we talked about, or your unit test is wrong.
Yeah, but there is a lot of configuration as well, and in the serverless world, because there is so many integrations to services. So can you unit test those?
I would say you can do some things through the CFN lint with custom rules and so on, but that becomes very complex very fast. You can test some things like making sure I have a dead letter queue, for the asynchronous invocations, right? That's an important thing to check, and that's actually much harder to actually test if it's working properly on top of that, right? But if I want to test that I'm sending the right DynamoDB table name and so on, like how do I write a test for that?
Exactly.
Because
I don't know.
I mean, do I force everyone to use a DynamoDB, like a very specific value for the environment variable so I can check that? It gets very complex very fast. So that's kind of where the integration tests come into play. But going back to this, so if I go a bit into the order service, so you see here the structure. So this is my template with my CloudFormation file. Metadata, that's something I use as part of my tooling to know that it's a service and so on. But I have this test folder when I have my two level of test for the service, right? The unit and the integration test. In the units, I have a different, for each Lambda function, I will have a different test. And so if I go into, let's say, table update, so that's a Lambda function that's triggered by DynamoDB stream. So whenever there is a change to my DynamoDB table, it will trigger this function. I had to do some smart things because of the way Python works in Lambda. So the way you add modules is that you can just add them at the root of your Lambda function. But now I have this question, how to make sure I import the right one, and I want to test multiple functions. So I created, in PyTest, it's called a fixture. And it's basically a tiny utility that I can use in all my tests. And that will bring me my Lambda module, where I have my handler and my logic and so on, so that it's easier.
So then from there, basically, you are faking the parameters that Lambda receive, like mocking them with the unit test.
Yeah, I'm faking the environment variables. I'm faking the import path, and also as part of that, also restore it when I'm done.
Yeah.
Once I'm done, and then I also do a few fixtures. I'm a big fan of random generation for tests. So here, every time, for example, because this is the order service, going to get order requests, I generate random ones. And you might say, hey, but what about consistency in your test? Well, these should all work, right? If I have a test that fails because that's supposed to be a valid event. If it fails, it means that something is wrong, right? Even if it's failing only once every 10 times or something. And so I have all these fixtures that mimic a bit how everything looks, and then I'll have the test, where I test the individual function in my code in isolation. So sending events, which is the function. And I like, we talk a lot about adapters and ports and splitting. So that can also, in my code, I can also switch. I'm using Event Bridge today, but tomorrow I can use something else if there's something better.
Yeah. Right? So how you use some kind of modules that you kind of wrap up your event bridge or something like that?
Yeah, it's the function send events in this case, and it will just take the series of dict. Yeah, so the series of events, and then put them on the event bridge. Yeah, and I think that's always nice too. Then you can replace it with whatever. And if you have a bigger project, then you can even have a whole module or file or class or whatever it's called in the language that you're using. Yeah, like that's very language dependent. Right? But the thing that's important here is, so I'm using something called stub. It's part of the Boto3 library. Because, there's also another library in Python called Moto, which is very convenient for mocking things. But I'm just defining my response completely manually here, saying, hey, this is what it should look like. These are the expected parameters for my call. I'm just putting this, and I can validate that I got the call the way I expected it, and that's it, right? So, because we didn't touch a bit around we touched around DynamoDB local, but you have all these other AWS services that I need to mock when I test things locally. So you're in here testing Event Bridge, for example. And yeah, I'm not running Event Bridge, I'm mocking Event Bridge. So you're mocking Event Bridge, and then you are passing this, I don't know, what you're passing to this mock. So when you define the mock here, I'm saying these are the parameters I'm expecting. This is what it should look like. Yeah. And if my function send events doesn't send the right parameters to the AWS SDK, it will throw an error instead. Okay. So. And if it's not called, it's going to throw an error as well. So I can make sure that it made the call the way it's supposed to be. So that stubber is the one that will help you for that. Yeah, exactly. And going back to the layers of test, that's kind of the thing that if I might be wrong here, but because I have this integration test later, I can go back. If my integration test fail, I know like, hey, I was wrong on this aspect. Yeah. Cool. So this is how you do it for all the different services that you are integrating through the AWS SDK, basically. Yeah, while it's unit test, I'm mocking everything. Yeah. Because I'll test them later. Yeah, sure. Right? You don't need to test if Event Bridge is working. Yeah, exactly. And so from the developer point of view, if I just go back here, I can type make CI, and this will do lint, build, and unit test. And once again, for the building, here it's fresh install, so it's going to build all the functions. But when you redo it again and again, it use checksums for the code to validate if it has changed or not. But here it's going to install, so the first time is a bit longer. But then it will validate that, it will run all these things. You got errors. The good thing from a developer. Yeah, but That's just PIP. Don't worry about that.
Those are good errors.
They are good errors. They are normal errors. Like it's like when you build things and you get warnings. It's the same thing. If you don't get warning, did you really manage to build the thing you were building? But the thing is that for developers, just always make CI. And we go back to this makefile. If I have something that's using another programming language, I was mentioning that I started playing with Rust a lot. Well, it's still going to be make CI. I have this makefile on each project that contains instructions specific because maybe for each service, because different services could use different languages. Yeah. And I can say like, hey, this contains an open API, this contains Python 3, this contains CloudFormation. This gives that flexibility to change things.
And do you use this makefile in your CI/CD in the, for example, code builder or something like this?
Yeah. It's because the benefit as well is, let's say as a developer, you do your things locally or on your own AWS account and you're testing everything works, but then the CI/CD pipeline actually works differently. That's going to be hard to keep everything consistent. The makefiles are a great way to keep everything consistent between the dev environment and the CI/CD pipeline.
So code build can use makefiles.
Yeah.
Nice.
Yeah, code build is just it's going to be Linux most of the time, so you can run anything.
So in
there,
your spec file, you say, okay, just use the makefile, and then that's how it goes. Yeah. Okay.
I just noticed that I didn't run the right service. If you tap make CI, it's going to do the CI for all the services, which is also convenient if you want to check everything works well.
I thought that you were doing that.
It makes CI orders. Now it's doing the right service.
It happens.
And so, it goes again, build everything, and then it will run the test. But the good thing is that because actually it started testing, that's what ticked me. There is one microservice in Node, just to show how you can have using Node and CDK, just to show how can you have something in a different, in a different framework, in a different language. And I noticed it started to do testing for Node, and I was like, oh, that's not normal for this microservice.
Nice. So that's another thing you can check in this e-commerce platform, how to do mix and match of different languages and frameworks. That's nice. Yeah. Which one is the Node project?
So actually, while it builds, I'll show a bit the architecture diagram. Okay, so while the tests are running, I'm just going to show a bit the architecture for this. So the dotted lines that you can see all around, these are kind of the boundaries for each microservices. And by the way, it doesn't show all the Lambda function for each service, right? It just shows that there is this integration, how they work. It's just to have a simplification, right? But as you can see, so the one in Node, that's the payment third-party service here. The idea was I didn't want to play favorites. I didn't want to use any specific provider. I know Aether in the airline application did so, but I wanted to keep it open. But of course, when you process payments, you usually don't want to deal with credit cards yourself. So use a third-party service for that, and that's kind of what it does. You put the payment details, so card details, payment amount, it returns the token, and then that will be used for the rest of the platform there. But so for the end user perspective, you have this AppSync API. So this way you have a nice GraphQL unique endpoint for all the microservices behind. And already mentioned a bit around EventBridge. You have EventBridge here as kind of the communication between all the different microservices when we can do asynchronous, right? And you also have some API gateway. So if I go through a sample case, when a user is creating an order, so that will go to this Lambda function here that does the validation. And then when it's good, so the validation has to go through different microservices, validate the products, the payment token, the address, we can actually deliver there. And then once it's done, it's going to store in DynamoDB. And then from there, you have DynamoDB stream that will trigger a Lambda function that will put an event on EventBridge. And then from there, you have the warehouse service that picks it up, and so that's kind of the flow and how all the interaction.
Why you have the API gateways for internal communications?
So it was just easier. I like to use IAM for service-to-service authorization because since we're already in AWS, all my Lambda functions have an IAM role because they need to. That was just easier to do it this way. So the internal calls use IAM for authentication. And this way they all have that. I can use OpenAPI. The benefit of OpenAPI there is that you can take that, show it to the team, you have it as part of your documentation. It's like, hey, this is my API, how it works. We talked a bit about contracts earlier, but because of how API Gateway works, it's actually the piece that you use to deploy the API at the same time. And I found it to be really elegant because you have this documentation and code, in the same artifact. Something that's used for both sides. So I found it to be quite interesting there.
And why not to use Event Bridge, for example, for internal communications?
So that's and I have a really good case with the delivery service, for example. So when you have a package created, the warehouse service emits an event that's picked up by the delivery, but the delivery only knows that this is the order ID, but I don't know which address to send it to. It needs to contact back the order service. It's a question of simplicity.
Yeah.
Because then I can just do a synchronous call there. Or in the case of creating the order, let me show another diagram for this.
Yeah. I think one of the main reasons is you want the response back, basically.
Yeah. You could say, hey, you can do asynchronous responses and have it so on.
Yeah.
But when you start thinking about failure modes, that adds a bit of complexity. So, for example, when you create an order, you want to have the response, very fast, and to say to the end user, like, sorry, your order is not valid. You don't want to send them an email afterwards, 3 minutes afterwards that it was invalid, right? So the synchronous here, it's a bit of a pain point because it adds more risks, but it was just easier to do for these use cases.
But I think it's a real use case, so why not to model it? Because it's part of, like, as you said, you want to have the fast response, so...
Exactly. And I think it was something interesting as I started designing that, showing that you don't have to be 100% event driven, right? Make something that works for you. Make something that's going to, it's about making your life easier, not harder, right?
And I think it's being conscious about why you take some decision over the other, because that's, I think, one of the most important ways of designing services is not making the book correct answer for everything. Yes, we are in serverless, everything should be asynchronous, everything should be event-driven. No, but if you need, in some particular cases, to do it the other way around, you know why you do it. There is a reason. And I think that's the most important thing when you're designing any service, that you have a reason why to choose something that is not the recommended or the book answer for them.
That actually leads me, there's something I try to do. It's not perfect. But as I did a bit of the decision log, and I think it's very important when you have this kind of decisions to explain, hey, why did we do monorepo? Why did we choose this option versus another one? And so I've tried to document a bit why, because sometimes it's not clear cut, right? There are lots of cases where both are valid. We just have to settle on one, right?
And I think that's something that it might be a thing from the moment that it's what you have available, and maybe later you can change, or it was a real clear decision why you made it. and I think it's really good to document those architectural decisions, so then people are like, well, we use this because.
And I like it from the perspective, I like to think about it from the perspective of, we have someone new on the team. How can I get that person up to speed? It's same. I like to think about of people, because we design systems for people, right? Microservice could be a team, but then we have this new member of the team. How can I get that person up to speed and explain to them why did we do this decision? Especially if you have someone curious and creative, that's like, hey, why not this? And you might have a very good reason there. That helps a lot.
Yeah, and it also helps to, like, in the future, if you want to migrate out from, I don't know, the decision that you took, you can go and revisit why you choose that, and are those things cover when you are migrating out or moving out from there. So that's really nice.
Yeah, and actually that's why I prefaced this page with the section from the Amazon's letter to shareholders around the two-way doors, which is something very Amazonian. Is if you have a decision that you can reverse in the future, like, take it fast, right? If it's a one-way door, we can't change that. We need to take the time to think about it.
Exactly, and I think that's always very good for anything in life.
Yeah. It's a really good principle to live by and to design by.
Yeah,
Yeah.
that's cool.
But going back to the test, so now you can see that the test, I mean, there are some warnings, as I said, if you don't have warnings, are you really
Didn't do
testing
anything.
something? But it's just some warnings from a library that emits them, but all the tests have passed, right? And now, because this was the first run, it's built all the Lambda function, and if I do it again, now, because I didn't make any change, it doesn't need to rebuild. So it's still going to do lint and so on. So it's still going to do take a bit of time. So yeah, going to do linting. Building will be very fast now because checksum is matching. And then we can directly go into the test. So
Nice.
once again, it's getting that feedback loop as fast as possible. So as you can see, like that was a totally appropriate time, I think, to run all the tests.
That was really nice. And I imagine if you change something small, it will not take that long either. It will just build that function that change or something.
Yeah. And now that leads me to the next step. Once you have all that, so in the original makefile, we have test and then check dependencies because you have dependencies between microservices, right? Package deploy, so package all the artifact onto an S3 bucket, deploy them on the.
And I think that's super important I get a question that a lot from when I talk about CI/CD, that you always package one artifact and that is the one that you're going to deploy in your multiple stages because that's the one you test and the one that is kind of you don't want to build a different artifact for each of your stages. So that's something I think is important always to mention, because sometimes you see the pipelines and they're like built everywhere. It's like no.
Yeah, and if you don't do version pinning for dependencies, for example, and there's a new update, then you might have actually issues there. But then after that, we can do the integration test. So I'll start running them here. So make test integ orders just to do one service. And while this runs, I'll show a bit how it works under the hood. And so once again, I have this test, but I have different types of tests because there is the test when I'm testing an API gateway. There are the tests when I have this Lambda function that's invoked directly. I have the test for when events are coming in, and you have all these scenarios that you need to test.
So you're not basically making like before for your unit test, you have one test per function, and now you have kind of one test suite for different categories.
Yeah. So test events are actually the thing that should trigger events, should result in events on Event Bridge. That's going to be, I'll show a bit, by the way, how it works, because testing event-driven is hard.
Yeah, these integration tests are hitting the real services deployed in some particular stage. So when you're running it from your console, are they hitting your development stage or something in the cloud? Is deploying or is creating a new stage? What is doing?
Yeah, it's I'd always default to the development environment. So that's the developers' own playground where they can experiment and so on. But there you can pass an environment variable called I think it's environment, and you can say like I want to actually run this test on the staging or the prod environment. Please don't do test on prod. I'm not a huge fan. If they don't have side effects, but these tests have side effects, so don't.
Yeah, that was my next question: how you handle side effects, or do you handle them at all, or you just don't care?
Yeah. So there's another layer of test that's because the problem with these tests, since I'm testing on a fully deployed application on AWS, if I'm testing something that emits an event, the other microservices that are listening to these events will react, and that's kind of where that's the side effects you have. But here you're actually testing on, so for example, test table update. You put something on. And there's this listener fixture, and I'll show a bit the architecture diagram of how I managed to make to test event-driven architecture to test that I'm getting events, because test asynchronous things, right? But I'm testing asynchronous things. How can I do that?
Yeah.
And so it listens on all the events from the orders microservice. And what it does is it puts an item on DynamoDB and then listen if we have an order created event coming in. And same when I'm changing the status to cancelled, it tests, all the modified, and it can do all these kind of tests there for this. And so as you can see here, I'm actually not testing the Lambda function itself. I'm writing to DynamoDB and listening to Event Bridge.
Yeah. So you're right, like how you're doing it. So you're writing to Dynamo?
Yeah.
Because I don't know what this function is doing, so that's also hard to.
Yeah, the function takes the function listens to the DynamoDB streams and puts an event.
So that's why you are looking to the streams.
Yeah. So if I show the diagram, this is this function here. So I'm writing to this table, and this will trigger this, which will trigger this. But the thing is, in the future, what if I want to change this? Or what if there's a direct integration I could use in the future, right? This way, because one thing that's important when you do integration tests, and you make architecture changes, is making sure that you're doing the same test. Let's say I'm changing my Lambda function for Fargate container. How can I make sure I do the same? That I'm actually doing the same thing? Because if I have to rewrite my test now, I'm not. How can I guarantee that my tests are working still properly? That I'm actually testing the right thing? Well, here I have this flexibility.
So that's how you're testing this asynchronous. That's interesting.
Yeah,
and I think it's kind of an interesting point for people that are thinking about doing the integration test, that they don't need to worry, for example, about the Lambda function. They just need to worry about the output of the Lambda function, basically.
Yeah, because this way I'm testing that DynamoDB streams to Lambda function is working and Lambda to Event Bridge is working. I still need to debug if something goes wrong, wherever it was, right? But now to actually show you a bit, no, that's not in pipeline, wrong one, platform, there we go. To show you a bit how I testing, there is this, show the architecture. So what I do to listen into the changes, I need to bring the event from Event Bridge back to my machine to be able to verify that, right? And I've used the WebSocket API for this. So whenever there is an event on Event Bridge, it actually triggers a Lambda function that look up who needs that event. And that allows me to do tests in parallels. So same thing, shortening the feedback loops. With this, I can do tests in parallels because I don't have, if I can have multiple listeners listening in at the same time.
Interesting. So this is something that you have developed just for the testing. Of the application.
It's heavily inspired from, because at first I did with an SQS queue. The problem with that is that you can't do parallel testing with that, and you couldn't do. I did a load test and then ended up with 500,000 messages on my queue with SQS. So that's kind of what I said. Okay, that doesn't work. Let's do WebSocket instead. And that was a bit more complex to set up, but now I can actually do all this test.
So then your CLI is basically poking to that WebSocket.
Yeah, exactly. That's kind of the listener fixture I just showed. Actually, does that. It's connected to WebSocket. Put the item in DynamoDB, for example, and then listen in for a set period of time. For example, 15 seconds.
Wow, that's interesting. So, what is the code for this? Because I imagine this is something that can be reused by some other people. Is that platform?
The code for the fixture. So, the platform, that's going to be where you see the CloudFormation template. So if I go into the platform and we go into, you have the source for all Lambda functions here, and you have the template containing all the resources to make it work.
Nice.
But, going back to the idea of making it easy for developers, in the test, so shared test, there is this integration, and you have the fixtures. And here you have this listener fixture that you can use for your stacks directly. So that handles all the complex things. So for example, here I'm using IAM to connect, authorization to connect. I didn't find a nice library, so I had to do that manually. But it's the kind of thing that you do once, and then you can tell developers, just use this one. It does everything you want.
Should put this as an independent thing, because I think it's pretty useful.
There is there is a customer that did that actually, and that's where I stole it from them. So I'm going to do credit where give back the credit where it's due.
Moutschen.
Yeah. It's so I'm based in Sweden. It's a Swedish customer. I don't remember where it was. Yeah, I think that's this one. No, it's not this one, but there is somewhere here. There is one of them that contains, all these things. They've actually done a lot of things around. If you want to use Eventbridge, there are lots of they've done lots of tooling around that with this tool here.
Nice.
That can help with tooling, writing the rules and all this kind of thing that can be a bit fiddly at first.
Yeah, that's so interesting. Yeah, I will link this repo in the description box so people can go and check it out as well.
Yeah. And so, we were talking about tests with side effects, but there is another layer of test I do which doesn't have side effects, which are the end-to-end test. The idea there with the end-to-end test is to simulate the user flow. I only have one scenario, which is the happy path when everything goes well, but you can create these scenarios where, for example, one product is not in stock. What do we do there? And you can start playing around with all the scenarios, and it will test the happy path.
What it means, the end-to-end test? What is the difference between end-to-end and integration test?
Yeah, so the integrations tests are still bound to a given microservice. So as in, you could, if you just update the microservice, it's just going to test this. It's not going to test the entire application. While the end-to-end test tests across all microservices.
And what is the difference? Because now there is this CloudWatch synthetics or something like that allows you to do this kind of end-to-end test or something like that. Have you seen it? That you put a URL and then you create a template. Is it similar?
It's similar. The only difference is this can run locally and run in my CI/CD pipeline. But synthetics can be really interesting if you want to do continuous testing, where you can run this test over and over and over and over to make sure that, are still things, is it still working as expected or not?
Good, because that's something I have seen. At least I've been talking with Nicolas Moutschen about CloudWatch some months ago, and he was mentioning this synthetics, and I was like, this sounds very interesting. But this is a different one. This is more for your CI/CD pipeline. I think that's
exactly. It's. I mean, you have the part. Reliability is part making sure that things that you're not deploying things that are broken, and part making sure that the things that are deployed are not broken. Right. So
exactly.
They have both different utilities. And actually, now that we have all these layers, so I mentioned the importance of doing that as a developer, as you code. But we can go now into the pipeline and have a look at what the pipeline looks like.
This is the folder that we were talking earlier when I was saying that this was a very creative approach, and I like it a lot.
So you have this first stage with code build that's going to detect the changes, and it's going to run the lint and unit test. So it's done, lint, build, and unit test, and package the templates already. So we already have the artifacts packaged, and store them on S3, and that will trigger the pipeline for each service. Since there are microservices, they should be able to be deployed independently.
Yeah.
But in a monorepo, don't do like large change where you change all microservices at the same time, changing contracts on. You should still consider them as different pipelines and different deployment cycles. But then through that, I can do deploy to test, where I will run the integration test, so without side effects. Then deploy to staging, where I run. Well, this is actually a replica of prod, where you can run the end-to-end test, and then when that's good, you can deploy to production.
Yeah, and I think in this example you don't have it like you can have a multiple account set up for this, but I imagine you can do it if you want.
Yeah. It's just a question of, and it's the same with, when we're just testing microservices or the ability to deploy an entire application. When you get an application that's very large, it becomes hard to deploy everything in one account, or you might want to have strict boundaries. So,
and I think even having multiple accounts for your production and the rest, it's a good practice.
Yeah.
So at least for that, it's not maybe even for each service, but just for keeping production.
Yeah, no, there's certainly kind of a matrix, right, between, if you think about domain-driven design, you could do an account per domain in prod, but then you have prod, test, staging, and
it can become a lot of accounts.
Yeah, it's actually, I get that question because I mentioned a lot the developer account, right? And I get a lot of questions around that. If you can do one AWS account per developer and it's not a burden for you to manage, like that could be really nice because everyone can experiment independently. But you could have an account per team instead. I like to call them playground accounts, or you can have one for an entire company if you're a smaller company. But you can this ability to experiment is very important to me.
Yeah, and I think this question also lead to the performance testing, because I think here is very important that you have an independent account for doing this type of tests.
Yeah, because you have the account limits. If two people are doing load tests at the same time, on different architecture, that might cause problems, right?
Exactly. So the first question that people ask always is why we want to load test in serverless. Should it scale magically and be like unicorns and rainbows? Why we want to load test?
Well, there are a few things. The first thing, I already mentioned it a bit with the MySQS queue that had 500,000 messages, right? So the first thing is, and it ties a bit to the question around cold starts. I hear lots of people complaining about cold starts, but when you just do you just deploy, do one test, deploy, do one test, you always have cold starts, right? Because every time you have a new version.
Yeah.
But at scale, how much are cold starts actually impacting you? Was this the average latency of your application, right? For example, I mentioned the order creation process where I have these synchronous calls. That was a thing that was really important to do with a load test. I could see, hey, it's on average taking 3 seconds. That's a bit long. And I made some changes, some optimization through that. I was able to bring that down to half a second instead, but it's going to be really hard if I just do one call at a time because I have all these cold stars that might not be reflective of what I'm expecting in reality. Then we already mentioned the account limits. I'm making sure that you're not hitting them. And another aspect there is the costs as well. It's one thing that's really nice on serverless with the invocation model where you pay per request or pay per resource utilization, you can have a very good understanding on how much is this costing me per request, or in my case, per order, for example. And then you can do the math backwards. You can say, hey, an order is on average this size, and I'm spending that much on AWS resources. Is it reasonable or not? I want to add a new feature. How much will it cost per order? And you can really do the math, because you can have something that double the cost of your infrastructure. But if it brings value to you, that can be a win.
Yeah, and I think it's very easy to run a couple of hours of load test and get your kind of hour value of your service running instead of going to the AWS calculator and trying to guesstimate.
Yeah, it's. I did a load test for 1 hour where I generated, I think, 50,000 orders and doing the whole processing and so on.
Yeah.
It ended up costing me $15 in total, right?
Like, exactly. And it's a control environment, because you say, okay, it's 1 hour.
Yeah, and then it goes down to zero after that because I don't have traffic anymore.
Exactly. So, and I think also another reason I will add for load testing, if you have third-party integrations, inside AWS things scale quite well, but sometimes the way that other services don't behave the way that we expect them to behave. So it's good to know that if we throw the load, for example, how Lambda is sending messages to a third-party service in parallel 1,000 times. Can that handle it?
Yeah. Or
how that behaves.
On the other side, you have things like DynamoDB, which often perform better when you start to have lots of traffic to it.
Yeah. So there is a lot of things that change on load. How do you do load testing in serverless?
So, I already mentioned a bit the random pattern generation I was doing, right? And I actually took, in this case, because I have this, so in the shared, you have this perf folder, happy path, and you actually see that it will mirror the end-to-end app happy path, because I used a Python library called Locust, And because I already had this test in Python, I just took my end-to-end test and made it into a load test. This way I was able to test the entire flow. So because I think when you do that, it's also testing something that resembles, some form of production traffic, right?
Yeah, definitely.
And then from this test here, I actually have so I mentioned, the random generation of products, and random generation of addresses, creating the user and so on. And then it just does, all the operations, all the calls and so on. So yeah, so start.
And this, you're running it locally or you are putting it somewhere in the cloud? Because at least when I've been trying to do load tests from my machine, it sometimes kills my machine.
Yeah. In general, I think if I'm doing a very small test just to kind of check, it's fine. But yeah, I mean, you can just spin up an EC2 instance. The good thing is that then you have the AWS local network, because if you deploy it in the same region, you don't have your latency having any impact on this. You don't have your internet connection having impact on this.
Exactly.
So that helps a lot. Just spin up an EC2, run the test, shut down the EC2. Don't forget to shut down the EC2 instance afterwards. Because if you are like me using serverless a lot, you might forget about.
Can you do this from Cloud9?
Yeah, that could be done as well. I mean, Cloud9 is
just thinking about, and it has this timeout thing that when you stop using it, it starts off. So,
Cloud9 is really nice. That auto turn off for Cloud9 is really nice.
Yeah, and you don't need to set up almost anything to get started with the EC2 instance. You just put your code and you can do things. So
yeah, I mean,
if you're not very familiar with EC2 and how I use this, then it's just an IDE.
Yeah. I mean, here we see one IDE, but you just clone the repo in that IDE, and you can just do the same thing you've been doing on your local machine.
Exactly. So maybe, I don't know, I need to try if I can run load tests from Cloud9. It will be interesting to see, because it's a very powerful IDE.
Yeah, it is. It's been very helpful. And for me as a solution architect, it's been quite helpful.
Yeah, I like it a lot for demos and things like we need to have like if I need to share something or do pair programming, it's really cool. So now we have all these different levels of testing, and you mentioned that these are all integrated in the CI/CD using code build. So basically, in every different step, we will be running these different commands from the makefile to run it in the right point on the CI/CD pipeline. So now we have the full picture on the testing.
Yeah.
So we will run the linting and the unit test when we are developing, or at the beginning of our pipeline when we get the code from GitHub. Then we run the integration tests. Then we deploy and we run the end-to-end test. And I imagine the performance tests, you don't run it all the time. You just run them when you want them.
Yeah, no, it's more because it's when I made a significant change. I want to make sure that the financials are still correct, right? These kind of aspects.
Exactly.
For example, an e-commerce platform, you might want to add a recommendation engine. That means machine learning, so on. How costly is it going to be, right? And you can do that with performance tests and understand the value of it.
Exactly. So now we have all the different levels of testing in place. So it should be totally integrated in your deployment and also in your coding practices. So
yeah, invest in the right tooling. These makefiles, like the ability to just do make CI the name of my service and so on. That saves lots of time. And as I said, if you have different settings and so on, different microservices, because you're changing technology, you might have started with CloudFormation and now you started to use CDK or something else. Having something that's abstract that away from the developers and they can just do one command is a lifesaver.
So is there some good resource for getting started with makefiles or makefiles with, I don't know, you're using SAM or things like that?
I mean, makefiles are, I wouldn't say that they're completely straightforward, right? But it's what you define, just to showcase a bit, you define a target, for example, integration test, And then you just put the commands that you want to run inside it. And it will do that for you, right? So the easy steps is kind of, it's easy to get started, but then you see there's actually lots of trickery. Like I have this certain sign, I have
exactly.
But feel free to just, this is an open source project. If it can be helpful for you, copy and paste what you want, and experiment. And again, you can ping me if you have questions on that. I mean, I'm not going to do an intro to make files, right? But if you want to do something similar, I'm happy to help. Because
I think this is at least a quite different way of making these projects. So I think a lot of people will be interested in looking at make files and see how they can integrate them with their projects. So that's really cool. And it works for any language, because at the end of the day, it's like bash scripting or something like that. So if you have Node, Python, Java, whatever, it should be.
Yeah, that's the thing that's made me interested in them. It's if I just show, just to compare, for example, I have all these utilities to help with Python in CloudFormation, but I have this third-party service here. Well, it's going to have its own makefile where you just put the instructions like this.
Yeah, so you do npm, well, you're using npx and blah, 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 all the commands from Node. So it's pretty nice. So I think it's something that I imagine a lot of people will get interested in looking at these makefiles and see how they can integrate them into their flows.
And the good thing is it's repeatable, right? I don't need to rethink every time, that's the exact command I need to type. I have something that does it for me.
Yeah, and I think that's a nice thing of automation in general. Like, you can automate things and then you don't need to worry anymore. And then when you start a new project, you can copy paste from your previous automations and maybe just change, or not even, because if your file is called template YAML and it's in the build, so it's just basically copying that file and reutilizing.
Exactly.
And that's a nice thing of scripting.
I do way more copy and pasting than I'm willing to admit.
We all do. And I think that's a nice thing of having automation and infrastructure as code and all these kind of things. I always start all my projects with copy pasting some serverless template, or even starting from a serverless template and then changing one name here and then, okay, now my Lambda function is a different thing, but I need an API gateway, I need a Dynamo table. I already have built that. It's just like, I will type it again.
There's actually lots of cases where I don't remember exactly the syntax. I just go back to one of my other projects, copy and paste, and there we go.
How many times? But yeah, I think we have covered quite a lot of things in the testing world. So this was really, really nice. Do you have something to add or some more materials to share before we wrap up?
Oof, that was already a lot of things.
I know.
I know that. I mean, as I said, I try to do the best I can on the documentation for the e-commerce platform. There are lots of architecture diagram for each microservice. Try to document the code as well. So explore, take your time. In the GitHub repo, if you have questions, there's the issues. You can ping me on Twitter for this. But yeah, it's lots about exploring. And as I said, if you want to copy and paste what I've done, copy and paste it, right? It's available under MIT 0 license, so you can just copy and paste it.
Yeah, so don't feel ashamed of copy and pasting. We do it all the time. So yeah, thank you very much, Nicolas. This was really nice. I learned a lot about testing, and I hope the people watching also have learned a lot, and they have an amazing resource to explore. And that's the way to learn. Go and try it out.
But thank you very much for having me. That was great, an opportunity to share, something I spent lots of time building and putting, my energy into. Hopefully, it's going to be helpful for you listening to us right now.
Yeah, I imagine you put a lot of time on building this. It has so many pieces. And it's quite well documented. So I think it will help a lot of people. And it helped me, at least when I was looking at it a lot, how you build it. So I hope a lot of people also get inspired by this repo. So thank you. And I hope to see you again in another episode.
Yeah, same here. Thank you very much.
Thank you. Bye-bye.
Yeah, goodbye.
This was the interview for today. Thank you very much for watching until the end. All the links are in the description box. And I have to say, we don't have more slots for the fall season of this series. But if you want me to talk about some particular topic, I can start collecting for the spring of 2021 who you would like me to interview, which topics are you interested in, because re:Invent is coming soon and I'm pretty sure you would like to know everything that will happen there. That's it for today, and I see you in the next episode of FooBar. Ciao, ciao!